Hello friends, in this video we will be learning unit step signal in discrete time domain. Let us begin. So this is how unit step signal looks like. First of all, it is designated as u of n. So as you can see on the time scale we have n. So from the graphical information, at least what I can see is u of n is always equal to 1, but this is true only when n is greater than or equal to 0. I can write equal to 0 because at n equal to 0 also I can see that u of n value or magnitude is 1. And again, it does not exist otherwise. So for n less than 0, u of n is always 0. Also, I can write this in sequential form like this. So sequence form of u of n can be written like this. So again, there are zeros, and right from n equal to 0, it is always 1. So this is continuously 1 thereafter. So these are infinite series of 1. So this arrow mark indicates sample position at n equal to 0. And of course, after that, naturally this becomes position at n equal to 1. This becomes position at n equal to 2. And this becomes position n at equal to minus 1. Because we know that n is always integer, right? So n belongs to integer only. This is the in fact rule that we have already studied while learning discrete time signals, right? So now we will see what is the difference between continuous time unit step signal and discrete time unit step signal. So difference between unit step, continuous time signal and discrete time signal. First of all, I'll write a continuous time signal here and I'll write for discrete time signal here. In continuous time signal, unit step is denoted as u of t, and here it is denoted as u of n. Is that right? Next, when we describe u of t mathematically, we write it like this. U of t is always 1 for t greater than 0. It is equal to 0 at t less than 0, and it is equal to half at t equal to 0. We know that at t equal to 0 there is a point of discontinuity. So we write u of t equal to half at t equal to 0 by using a Gibbs phenomena. Whereas in discrete time signal, we describe u of n simply. U of n is always 1 even for n equal to greater than or equal to 0, and it is equal to 0 when n less than 0. So the first difference what I get is at t equal to 0, you can see magnitude is not 1, it is half. But here, even at n equal to 0, magnitude is still 1. So this is the first difference that we have in continuous time signal and discrete time signal unit step signal. Secondly, we have also studied like this. That is, if I take derivative of u of t, it is always del of t. I'm sure you remember this. Derivative of u of t gives you del of t. So as I said earlier in the last lecture, that derivative and integration have got no place in discrete time domain. In discrete time domain, instead of derivative, what we have is a difference equation. I repeat, differentiation in continuous time domain becomes difference equation in discrete time domain. So derivative and integration does not exist. Integration becomes summation and derivative becomes difference equation. So now I can represent it like this: u of n minus u of n minus 1 is what we called as del of n. In fact, I can show you how this has come. So u of n, you know that it is a signal having amplitude always equal to 1, right form n equal to 0, n equal to 1, n equal to 2, n equal to 3, n equal to 4, and so on. So this amplitude is always 1. This is u of n. Let me represent u of n minus 1. Now you know that u of n, if it is known to me, how to go for u of n minus 1? It is same u of n, only getting delayed by 1 unit. So whenever we delay by 1 unit, we shift the signal to right hand side by 1 unit. Therefore, if I say this is u of n, then I can draw u of n minus 1 like this. So there is nothing present at 0, but from 1 onwards, we will have magnitude equal to 1, and this is infinite 1, and again here infinite times of 1 is there. So between u of n and u of n minus 1, what I'm actually carrying out is a subtraction. Am I right? So let us see what happens at n equal to 0. At n equal to 0, value of u of n is 1 and value of u of n minus 1 is 0. So 1 minus 0 becomes 1. Is that right? I'm talking about n equal to 1. Check what is present at u of n at n equal to 1. It is 1 only. And what is present at u of n minus 1? This is also 1. Now if you subtract 1 minus 1, you will get what? 0. So you'll get nothing at 1. Similarly, u of n at n equal to 2, it is 1. And u of n minus 1 at n equal to 2 is also 1. Again 1 minus 1 will become 0. So I hope you understood that I'll be getting no samples henceforth. And of course, there is no question of getting samples at negative time scale also. And looking at this graphical representation, one can easily say this is nothing but your del of n signal. So u of n minus u of n minus 1 gives you del of n in discrete time domain, whereas in continuous time domain, only if you take derivative of u of t, then only you will get del of t signal. So I'm sure now you got the clear-cut difference between unit step signal in continuous time domain and unit step signal in discrete time domain. Please remember these things, that integration and derivative does not exist in discrete time domain. They are valid only and only for continuous time signals. In continuous time signal, if we have the integration, it becomes summation in discrete time signal. If we have derivative in continuous time signal, it becomes difference equation in discrete time signal. Thank you.